Okay. Hi guys, I'm going to quickly show you how to use Logger Pro to do video analysis and motion capture. Now you can get Logger Pro from Software Center and download it, and when you open it up you will get to this screen, which is just the default screen. Now you can plug in LabQuests and sensors, and it will auto detect the sensor and set up the columns and axes appropriately. But today what I would ask you to do is we're going to look at inserting a movie. Now obviously you'll use a movie that you've taken with your laptop camera, but for today we are going to use, oh dear, where are they? I'm going to have to restart this damn, where is the folder that says original video files? There we are. There are some videos that are already like some sample movies. Now, before we commence, the thing about this video is, and the video that you take, the action has to stay in the frame. So if we look at this ball, it stays in the frame, which is great. And the next thing is you can't have the object traveling away or towards the camera. It has to travel perpendicular to the direction that the camera is facing. Okay. Another thing is, in the frame there needs to be a known scale where the object is. Now in this, it could be the height of the person. If we knew the height of this gentleman, we could measure it, but there's actually a 2-meter ruler on the floor here which we're going to use. Okay, so what we're going to do is we're going to click on this button here, which will open up some video analysis, and you'll get these little tools on the side here. Now the first one we're going to do is we're going to set the origin. Now what I'm going to do is set the origin at his feet, and I might choose the y-axis to be where the ball is released from his hand. And so that will tell us where our data points are logged and the coordinates that they obtain. Next, we're going to click on the ruler and go set scale. And so we're going to highlight this ruler down here and from one end to the other, and we can call that 2 meters. So it wants to know the distance in that is 2 meters. Next, as I said, you really want to get the ball as it leaves the hand, and that way it is traveling in a projectile path. And we're going to change the cursor to add point. Now, am I still going? Cool. Once we do that, anywhere I click on this grid will give a coordinate system, and you can see the coordinate system up the top there, and you can also see the time and the number of frames elapsed. So we're on the 7th frame and I've put a coordinate. Now what it does is it advances to the next frame and it tells us the time, and we are going to follow this object. Now you need to be consistent with where you are tracking and clicking. I'm choosing, there's a little reflection on that ball, on that top right corner of the ball, and so I'm going to just follow the top right corner every time. Okay, you need to be consistent. You don't want to be moving within that object. So it is a little bit tedious to do this, but I would suggest that you use a mouse or the trackpad. The stylus pen's not as good, but we follow it through, and you might notice in the background that a couple of different graphs are being generated, one being Y and one being X. We're going to keep following the object through to the floor. And for the sake of this tutorial, we're actually going to follow it for one more bounce. Up he goes. If you do make a mistake, you can Control Z to undo. You can also highlight the data in the table to the left, and you can opt to delete it. So let's just quickly follow this through. About to fall back down. Now I'm rushing this a little bit, so my curve is not going to look the best, but we've run out of frames. Now the video has run out, but your video may continue on for a few seconds. So what I recommend you do, go back up and change your cursor to the arrow, and that way you don't accidentally click any extra data. Okay. Now, if you were to accidentally click on the graph a little bit preemptively, you can always, it is behind there, it's just hidden, you can bring it to the forefront, but we're done with the video now, and so we are going to have a look at the data. Now, conveniently, it gives us position time on our Y and X axes, but we don't want X at the moment, so I'm just going to select Y. Now, you can grab these axes and you can shrink them and stretch them. If you ever get stuck, that big capital A there auto scales your data so that it fits nicely. Now, what we can do here is we can do a number of things. We can simply move our cursor along and it will give us position as we scroll through time. We can find tangents, so you can slide your time along and it will tell you the tangent of the curve that fits the data, which is quite cool. But the most important piece of kit here is the curve fitting option. So what we have is linear fit or curve fit. Now obviously I'm expecting this to be a quadratic. So when I go in here, you've got all of these different equations that you can try and fit. So we could try and fit linear, and if we try and fit, you'll notice it tries its best, but you'll notice that the correlation is quite poor. So obviously it's not linear. If we go to quadratic now and we try and fit, we get a correlation of 0.999758, which is pretty darn good. And so I will click OK for that. Now it gives us a bit of data. It gives us an uncertainty of the data, which is quite useful. It gives us B, which is the initial velocity at time 0, and it gives us C, which would be the y-intercept at time 0. But unfortunately, we didn't plot this at time 0. Go away. We plotted this at time... Go away. That's quite annoying. We plotted this at time 0.24. So in this, we can't really use any information from B and C, but A should be a half of gravity. And in this case, it comes out as 9.4, which is a little bit low, possibly because I didn't accurately highlight the scale. This 2-meter ruler, I might have gone a little bit short. I could go back and reset the scale. That would obviously, that would be faking the data, but let's try it again and reset the data, make it a little bit longer, call it 2. And if we go back now, oh look, we're suddenly now at 9. It's actually gotten worse. Oh well. We can highlight this second section and do the same thing, curve fit quadratic. And we should get something a little bit higher over here, 5.2, which brings out 10.4. Just be careful if you have two separate trajectories, and if you were to suddenly just click curve fit, it's going to try and fit the whole thing. So have a look here, it's trying to fit a parabola to all of the data, and if you look at the correlation, it obviously is not close. So in this case, we would have to cancel and simply, let's auto scale that, and simply highlight the required part of our data. Why is it not auto scaling? Let's bring it down a bit. If we click on the y-axis, we can have a look at the y velocity, and we get two nice straight lines, which tells us that the velocity is changing at a constant rate. In this case, we don't want curve fit. We could go straight to linear fit, and that will give us the gradient, in this case 9.3. And if we highlight over here, now just be careful. Obviously these last 3 dot points, maybe it hit the ground, and these dot points here, maybe it hadn't left the surface. So just be careful that you're highlighting data that you know to be linear, and we get 10.68. Another interesting feature that we can use here is the integral function, which will give us the area under a curve. So if I integrate this part here from the initial velocity to its highest point, that should give us the upwards displacement. And it's telling us that the upwards displacement was 0.94 meters. We could then highlight the downwards path of its journey and integrate under that curve, and we get -3. So that makes sense. It went up by 1 meter and then down by 3. So we can do this again, highlighting the areas that you want. The second bounce traveled up by 1.45 and then down. Well, the video cuts out, but that's just a few different features that you can use. There are many, many more features that you might discover. There are tutorials that you can run. You can open up tutorials in Logger Pro. One other cool thing is you can export this data. There it is there. You can export it as a CSV, which will enable you to open the data in Excel. And it sends all of the data across with the units, and the formatting's already done. And so you can play with the data in Excel as well. You can, if you have too much data, this is what, 67 frames, so that's not too much data to present in an investigation. But the way we're going towards is using the software on your Surfaces and Microsoft devices. You might decide to use motion capture in your Year 10, Year 11 or Year 12 investigation. One last thing that's interesting is there are many, I didn't show you all, many different equations that you can try and fit: inverse square, natural exponents, sine waves. So for example, if you think that if you're doing an investigation on simple harmonic motion and you have a pendulum or something that might be rotating at a constant rate, you can try and fit a sine curve. And within the equation, then B would be the angular frequency, C probably the phase shift, and D would be the y-intercept. Obviously, you can see it's trying to fit a sine curve to our data. It's not a sine curve. The correlation is a little bit weak for this set of data. So we'll cancel that at this point. But hopefully you find this, tutorial useful. Auto scale there brings it back. If you ever get lost with your stretching of your axes, where's the stretching? There. You know, if you ever get stuck and it's starting to look a little bit silly, you can just go straight back to auto scale. So I'll sign out for now. Hopefully you find this video tutorial useful. And we'll turn off that.